is a stoichiometry and stoichiometric calculation, or stoichiometry and stoichiometric calculation. What do you mean by stoichiometry or a stoichiometry and its calculation? So we know in a chemistry there is a reaction. Most of the chemicals are reactions are there. So in that reactions, one part is called as a reactant and another part is called as a product. The calculation of mass involved in the reaction, that is called as a stoichiometry. So much grams of reactants are there. If it reacts, to give how much grams of product, or in terms of moles, or in terms of if it is a gas, it is in terms of a liter or centimeter cube. So ಇಷ್ಟು reactant ಇದ್ರೆ ನಮಗೆ ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಬರ್ತದೆ, ಎಷ್ಟು ಪ್ರಾಡಕ್ಟ್ ಯಾವುದು ಎಷ್ಟು ಬರ್ತದೆ. So that is known as a stoichiometry and it's a calculation. So stoichiometric calculation, and it is a calculation is applicable only for the balanced chemical equation. You have to write it in a balanced chemical equation. So that is called as a stoichiometry or stoichiometry and a stoichiometric calculation. It is nothing but the deals with the calculation of mass of the reactant as well as the product in a chemical reaction. And to get the calculation, you have to take the balanced chemical equation. Okay. For example, if I take a combustion of methane gas. Methane is a gas, combustion of the burn one. So that is the matter of burning in the oxygen gas. Okay, what it gives, we know you have studied in high school, the alkanes on combustion. It gives a carbon dioxide as well as hydrogen is converted as a water vapor. So this is called as a chemical equation or a reaction, but it is not balanced ಆಗಿಲ್ಲ. ಇಲ್ಲಿ ನೋಡ್ರಿ, ಇಲ್ಲಿ ಒಂದು ಕಾರ್ಬನ್ ಇದೆ, ಇಲ್ಲಿ ಒಂದೇ ಕಾರ್ಬನ್ ಇದೆ. ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ 2, ಇಲ್ಲಿ ಆಕ್ಸಿಜನ್ 2 ಪ್ಲಸ್ 1 3 ಇದೆ. Means it is not a balance. So we can't apply the stoichiometric calculation for this. So to get the calculation, we must have a balanced chemical equation. So balanced chemical equation ಇದ್ದಾಗ ನಾವು ಅದನ್ನ ಸರಿಯಾಗಿ ಮಾಡಲಿಕ್ಕೆ ಬರ್ತದೆ. So how to balance this? So this hydrogen is 4 ಇದೆ. Here hydrogen is ಒಂದೇ ಕಡೆಗೆ. So ಇಲ್ಲಿ 2 ಇದೆ. So we must get a 2 hydrogen extra bond. Oxygen here it is 2, but here it is 3. So ಇಲ್ಲಿ 3 ಇದೆ, ಇಲ್ಲಿ 1 2 ಇದೆ. So it is not a balance. So we have to balance it. So to balance this, you require here 2 oxygen. So 2 2s are 4 hydrogen 4 ಇದೆ ಇಲ್ಲಿ. So let's get that 2. Okay. Now it is a balance. 1 carbon, 1 carbon. Okay. 4 hydrogen, 2 2s are 4 hydrogen. 2 into 2, 4 hydrogen. 2 2s are 4 oxygen. Here 2 oxygen ಇದೆ. Here 2 oxygen. Okay. So now it is a balance. So this is these are called as a stoichiometric coefficient. This is what? This is a stoichiometric coefficient. Stoichiometric coefficient. These both. Okay. So coefficient is whatever in the chemical reactions. So that is called as a stoichiometric coefficient. Okay. Now we have to explain this reaction. This equation we can explain in different ways. We can explain this in terms of moles. We can explain this in terms of grams. Then we can explain this in terms of all our gas. We can explain in terms of liters also. Okay. So first I will go for explanation of this reaction in terms of mole. So how many mole of methane is there? So this is nothing but 1 mole. 1 mole of methane gas combines with 2 mole. 2 mole of dioxygen. Okay, dioxygen. Okay, 2 mole of dioxygen. To give how many moles of carbon dioxide? It gives 1 mole of carbon dioxide and 2 mole of water molecule. Okay, so this is how you explain that in terms of mole. We know what is 1 mole means. 1 mole is not 1. It is a 6.022 into 10 raised to 23 methane molecule. It combines with or it reacts with the 2 mole of dioxygen. 2 mole of dioxygen means what? 2 into 6.022 into 10 raised to 23 oxygen molecule. It gives again this 1 mole of means that is a 6.022 into 10 raised to 23 moles of carbon dioxide molecule and 2 into 6.022 into 10 raised to 23 mole of water molecule. That is the number of water molecules. So this is in terms of mole and experiment. Now we can convert this mole as well as in terms of grams. Grams means what? Molar mass. What is the molar mass of methane here? Carbon raised to 12. Hydrogen is 1, but it is 4 here. 4 into 1 is 4. 4 plus 12. Same thing we can explain in terms of grams. 16 gram of methane molecule reacts with 2 into what is the oxygen here? O2 on there. 16 into 2, that is 32. 2 into 32 gram of means direct is a 64 gram. 32 into 2, 64 again. 64 gram of dioxygen to give molar mass of carbon dioxide as 2. Molar mass of carbon dioxide is 44. So carbon value is 32. 12 plus 32 is 44. 44 gram of carbon dioxide and water molecule, one water molecule is 18. So this thing you have to remember. Water is 18, carbon dioxide 44. ಇವೆಲ್ಲ ಕೆಲವೊಂದು ಕಾಮನ್ ಆಗಿ ಯೂಸ್ ಮಾಡೋದು ನಮಗೆ ನೆನಪಿರಬೇಕು. So 18 into 2 that is 36. So 36 gram of water molecule. Okay. So that is you can explain in terms of moles also, in terms of grams level. Next we observe these are in terms of gas. Gas dalide. So gas dalide we can explain in terms of volume also. Very important thing one more is here, that is 1 mole of any gas at STP means standard temperature and pressure. 1 mole of any gas. ಯಾವುದು ಗ್ಯಾಸ್ ಇರಬಹುದು, ಅದು ಮೀಥೇನ್ ಗ್ಯಾಸ್ ಇರಬಹುದು, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇರಬಹುದು, ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಇರಬಹುದು, ಕ್ಲೋರಿನ್ ಗ್ಯಾಸ್ ಇರಬಹುದು, whatever the gas it may be, 1 mole of any gas at STP standard temperature and pressure at STP. At STP. At STP, 1 mole of any gas occupies 22.7 liter. This is one of the important concept. 1 mole of any gas at STP occupies 22.7 liter. Okay. So now here 1 mole of methane means what? 1 mole of methane gas means what? 22.7 liter of methane gas combines with 2 into 22.7 liter of oxygen. This is 2 mole. 2 mole is 2 into 22.7 liter. Similarly here, this is again 1 mole. This 22.7 liter of carbon dioxide it gives, and 2 into 22.7 liter of a water molecule. Okay, so this is how you explain based on the chemical reaction. You can explain the things. One of the very important concept because it is also asked in the CET that a lot use agutte. You may give in terms of mole, you have to rotate in grams or grams and put in moles in one. Okay, and this type of calculation and reaction is known as the stoichiometry or stoichiometry. Stoichiometry and stoichiometric calculation means a proportion. Suppose I am having about 48 gram of methane is there. If 48 gram of methane is there, if I burn it, how much carbon dioxide I will get? So 48 grams of methane or 48 grams of carbon dioxide ಬರುವುದಿಲ್ಲ. ಎಷ್ಟು ಬರ್ತದೆ ಅಂತ ಗೊತ್ತಾಗಬೇಕಾದ್ರೆ you must know the reaction. Okay, so from this reaction we can calculate. So one of the very important concept for any of the industries. ಇಷ್ಟು ನಮಗೆ ಪ್ರೊಡಕ್ಷನ್ ಮಾಡಬೇಕಂದ್ರೆ ನಮ್ಮ ಕಡೆ raw material ಎಷ್ಟು ಇರಬೇಕಲ್ಲ. So we must have so much of raw material so that we can produce this much. Suppose instead of that we are having this much only. ಇಷ್ಟೇ ಇದೆ ನಮ್ಮ ಹತ್ರ. ಹಾಗಾದ್ರೆ ಎಷ್ಟು ಪ್ರೊಡಕ್ಷನ್ ಮಾಡಬಹುದು ನಾವು ಅಂತ ಹೇಳಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಲಿಕ್ಕೆ ಆಗುತ್ತೆ. Follow? So based on this concept, once again we are having more that terminology we are using, that is a limiting reagent. Okay, that we can take later. So follow here. Whenever it is a gas, it is on this form. That is at STP condition is there. 1 mole of any gas at STP occupies this much, 22.7 liter. Okay. So this is what we cannot say about stoichiometry. Okay, based on this, let us go for calculation. I hope you have followed here. So stoichiometry means what? It deals with the mass of the reactant. This is called the reactant, and this is called the product. ಇದಕ್ಕೆ ರಿಯಾಕ್ಟೆಂಟ್ ಅಂತಾರೆ. ಇಲ್ಲಿ ಎರಡು ರಿಯಾಕ್ಟೆಂಟ್ ಇದೆ, ಪ್ರಾಡಕ್ಟ್ ಇದೆ. ಪ್ರಾಡಕ್ಟ್ ಎರಡೇ ಬರಬೇಕಂತಿಲ್ಲ, ಮೂರು ಬರ್ಬೋದು, ಒಂದೇ ಬರ್ಬೋದು, ಡಿಪೆಂಡ್ಸ್. Okay. So this is the reactant and this is the product. So whatever the masses of these, or mass can be converted to mole also. So that reaction or that calculation or that explanation is called as a stoichiometry. Proportions ಆಗಿ ಇರುವಂತದ್ದು. ಯಾವ ಅನುಪಾತದಲ್ಲಿ ಬರ್ತಾ ಇದೆ ಅಥವಾ ಎಷ್ಟಿದ್ರೆ ಎಷ್ಟು ಬರ್ತದೆ, that is the nothing but stoichiometry and stoichiometric calculation. Okay. So we have explained in terms of mole, then mass, and in terms of volume. Now let us take on a problem on this based on the same reaction. Same reaction of the problem out there. Calculate the amount of water. Water means here in terms of steam only. Water molecule or water is the H2O. Calculate the amount of water produced by combustion of 48 gram of methane. Calculate the amount of water in terms of steam is produced by combustion is on burning with oxygen or air. That is what is a combustion. Combustion of 48 gram of methane. Now again calculate the amount of water. Yes, the water. Is it really 36 gram? ಎಷ್ಟು gram ಬರ್ತದೆ? When 48 gram of methane is there. So we know the equation. ಈ equation ಗೊತ್ತಿಲ್ಲ ಅಥವಾ ಕೊಟ್ಟಿರ್ತಾರೆ ನಮಗೆ. Otherwise we must know this balanced value equation. So it is balanced. Now if you observe here in this what in terms of grams taken, so 48 gram of methane combustion. So 16 gram of methane on combustion gives us 36 gram. So therefore 48 gram calculation ಮಾಡಲಿಕ್ಕೆ easy ಆಗಿದೆ. Okay. Can we work out here? From the equation, what we can write? from the equation 16 gram of methane. 16 gram of methane corresponds to ನಮಗೆ ಬೇಕು ವಾಟರ್ ಕೇಳಿದ್ದಾರೆ water. It gives a 36 gram of water. 16 gram of methane gives a 36 gram of water. So therefore one way to get 48 gram of methane. 48 gram of methane corresponds to how much? So how to calculate that? So cross multiply. So that's equal to 36 into 48 divided by 16. Okay. So that corresponds to how much? 16 ones are 16 threes are 36 into 3 108. 108 gram. You have to write the unit also. Now खाली 108 बोलते हैं 1 mark को बोलते हैं unit बदलना. Okay. So this much. Okay. So this is how to use the stoichiometric calculation. Okay. Same thing in terms of a moles per kilo. We know the moles. So 1 mole of methane gives you 2 mole of water molecule. ಅಥವಾ ರಿವರ್ಸ್ ಕೇಳಬಹುದು ಇಷ್ಟು ಗ್ರಾಮ್ ಆಫ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಬೇಕಾದ್ರೆ ಎಷ್ಟು ಮೀಥೇನ್ ಬೇಕು. Anyhow, we must know the how much mass is involved in the balance equation. ಆವಾಗ ನಮಗೆ ಮಾಡಲಿಕ್ಕೆ ಈಸಿ ಆಗುತ್ತೆ. Okay, I hope you follow this. So you must write a balanced equation. Then you can write that in terms of moles or grams or liters. Same thing now, same reaction. I will take one more example. How many moles of methane is required? How many moles of methane is required? How many moles of methane is required to produce 2.2 gram of. See here in moles here. How many moles of methane is required to produce a in the grams here 2.2 gram of carbon dioxide. Okay. So how many moles of methane is required to produce a 2.2 gram of carbon dioxide? Means here combination is what? Mole ಮತ್ತು grams ನಲ್ಲಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಯಾವುದನ್ನ moles ಅಂತ ಹೇಳಬೇಕು? Methane. So I will go with the methane in moles and carbon dioxide in gram. So in this equation if you observe, how many moles of methane is there? 1 mole of methane corresponds to means gives how much grams of carbon dioxide? Carbon dioxide 1 mole is out, but 1 mole of ಎಷ್ಟು grams? It is of 44 grams. It is of 44 gram of carbon dioxide. Therefore what? ನಮಗೆ ಏನು ಕೇಳಿದರೆ it is required to produce 2.2 gram of carbon dioxide. 2.2 gram of carbon dioxide ಬರಬೇಕಾದ್ರೆ how many moles of methane is required? Okay. Same method. 44 grams of carbon dioxide is obtained from 1 mole. Therefore 2.2 gram of methane is carbon dioxide is obtained from how many methane moles? So again cross multiplication ಆಗುತ್ತೆ ಅಷ್ಟೇ. So 44 corresponds to 1 mole. Therefore 2.2 gram corresponds to how much? So that is the name of the right is 2.2 into 2.2 gram into 1 mole divided by 44 gram. Gram cancels. Okay. 2.2 divided by 44. That many moles. Okay. So this corresponds to 0.22 means again 0. Then this 5. 0.05 mole. 0.05 mole. That is this much mole is required to produce 2.2 grams. So ನಮಗೆ 1 mole ಇದ್ರೆ 44 ಗ್ರಾಂ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಬರ್ತದೆ. ಅಂದ್ರೆ 2.2 ಗ್ರಾಂ ಆಫ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಬರಬೇಕಾದ್ರೆ ಎಷ್ಟು ಮೋಲ್ ಇರಬೇಕು ಮೀಥೇನ್? It is a 0.05 moles is required. So this is known as a stoichiometric calculation. So industry ಬಹಳಷ್ಟು ಅಪ್ಲಿಕೇಶನ್ ಆಗುತ್ತೆ, ಯೂಸ್ ಆಗುತ್ತೆ. So this is about the stoichiometry and stoichiometric calculation. Okay, I hope you all follow this. Now based on this one of the very important concept we have to remember that is conversion of mole into grams, grams into moles. Okay, molar mass ಗೊತ್ತಿದ್ರೆ ಹೇಗೆ ಕಂಡುಹಿಡಿಯುವುದು? Very important concept for a chemistry student. Number of moles equal to mass divided by molar mass. One of the very important concept, number of moles ಕಂಡುಹಿಡಿಯಬೇಕು. ಆವಾಗ ಕೊಟ್ಟಂತ ಮಾಸ್ ಎಷ್ಟು ತೂಕ ಇದೆ divided by molar mass. For example, ಇಲ್ಲಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ molar mass 44, ಮಾಸ್ ಅನ್ನು ನೀವು ಎಷ್ಟು ತಗೊಂಡಿರ್ತೀರ ಅಷ್ಟೇ, 2.2 ಗ್ರಾಮ್ಸ್, 0.5 ಗ್ರಾಮ್ಸ್, 1 ಗ್ರಾಮ್, 3 ಗ್ರಾಮ್ಸ್, ಎಷ್ಟು ತಗೊಳ್ತೀರ ಅದನ್ನ ಗ್ರಾಮ್ ಮಾಸ್. ಮೋಲಾರ್ ಮಾಸ್ ಚೇಂಜ್ ಆಗುದಿಲ್ಲ. ಮೋಲಾರ್ ಮಾಸ್ ಇಸ್ ಆಲ್ವೇಸ್ ಫಾರ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಇಸ್ 44 only. ಮೋಲಾರ್ ಮಾಸ್ ಆಫ್ ವಾಟರ್ 18, ಅದು ಚೇಂಜ್ ಆಗುದಿಲ್ಲ, ಮಾಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. So based on that we can calculate the number of moles. Number of moles equal to mass divided by molar mass. Next one is the number of atoms. Number of atoms ಅಥವಾ number of ions or number of particles, number of molecules equal to, what is the formula for that? That is number of moles into Avogadro's number, that is 6.022 10 raised to 23. Okay. Number of atoms, molecules or ions ಯಾವ್ದಾಗುತ್ತೆ ನಮ್ಗೆ ಯಾವ್ದು ಕಂಡುಹಿಡಿಯಬೇಕು? ನಂಬರ್ ಆಫ್ ಆಟಮ್ಸ್ ಬೇಕಾಯ್ತು ಅಥವಾ ನಂಬರ್ ಆಫ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಬೇಕಾಯ್ತು, ನಂಬರ್ ಆಫ್ ಅಯಾನ್ಸ್ ಬೇಕಾಯ್ತು. ಸೊ ಬೇಸ್ಡ್ ಆನ್ ದಟ್ ನಂಬರ್ ಆಫ್ ದಿಸ್ ಈಕ್ವಲ್ ಟು, ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ನಂಬರ್ ಆಫ್ ಮೋಲ್ಸ್ into, I will use a bracket here, number of moles ಅಂದ್ರೆ moles in number of moles into Avogadro's number. Avogadro's number is what? It is about 6.022 into 10 raised to 23. That is the number of moles into 6.022 into 10 raised to 23. So these are very important concepts. So number of moles can be calculated by mass divided by molar mass. Number of atoms irbodu, ions irbodu, particles irbodu, molecules can be obtained what? Number of moles into 6.022 into 10 raised to 23. So based on those, let us take a few problems in the next class. Okay.